Welcome to the class. In this section, we're going to be doing measures of central tendency. This is section 12.3 in your book. And in this class, we are going to be looking at data and sort out different terms that we need to learn. For example, we need to find what the means of a set of numbers is. The mean is also referred in some areas as the average, but in statistics we prefer to use the term the mean. There are other terms, like for example the median, that we are going to be studying as well, and that basically will give you the half point of the set of data. We'll be doing some calculations with this kind of thing. We also are going to be looking at the mode of a set of data. And the mode is basically those numbers that repeat, and it has to do with frequencies, how often they repeat. We'll also look at mid-range and also the range. That's part of the calculation that we need to do. And we are also will be getting into areas of calculating percentiles, quartiles, and so forth. So this is going to be a very rich class in terms of definitions. Take your time, don't go rushing into the material. Try to understand every concept, because every concept is critical, and for you to be able to solve the problems, you need to understand what the question is, what is that they're asking you, the definition that you need to apply, and also how to organize the data. One suggestion that I give is that when you're doing percentiles and you're doing quartiles, it's always a good idea to reorganize the data in ascending order. What that means is that you go from the lowest to the highest value and reorganize the data before you start doing whatever work you need to do. Thank you very much. We are now entering into section 12.3, measures of central tendency. That's the homework. Pages 753 to 755. Make sure that you do all those exercises. Some definitions. An average is a number that is representative of a group of data. Averages are referred to as measures of central tendency. The arithmetic mean, or the mean, is symbolized by X with a bar on top of it. So this is what we're going to be using as a symbol for the mean. The Greek letter sigma is like an M turned over. It represents summation. This is very important, this sigma. Now let's consider the summation of X, right? So this is considered the summation of X is equal to the sum of X. So we have an example here. If we have a set that is equal to 4, 6, 1, 0, and 5, then the summation of X is going to be equal to 4 plus 6 plus 1 plus 0 plus 5. And note that we include the 0. In statistics, every element counts, right? So make sure that if you see a 0, include it, because it's part of the set. So this set has 1, 2, 3, 4, 5 elements, including the 0. So when we do the summation, this is equal to 16. That would be 10 plus 6 equals 16. Definition for the mean, the x with the bar over on top. The mean, x with the bar on top, is the sum of the data divided by the number of pieces or elements of a data. So the mean is equal to summation of x over the number of elements, right? The zero is an element, so that zero has to be included as part of the numbers of pieces. So we have an example here. Determine the means age of a group of firefighters. The ages are 30, 21, 51, 37, and 51. So the mean is going to be equal to the summation of x divided by the number of elements. How many elements? 1, 2, 3, 4, 5. So we divide it by 5. So we have 30 plus 21 plus 51 plus 37 plus 51, and that's equal to 38 years. Right? Remember to always include the units. Now we have the median. The median is the value in the middle of the set of rank data. This is important. The term rank means that you have to organize the elements in the set in ascending order. It's always important when doing this. So in this case that we have here, example number 1, the set is already been organized for us. 21, 30, 37, 51, 51. And if you can tabulate it if you like. This is just to give you a representation, right? And to determine the median, what we need to do is that we take one element from each side. So we take one element from the right hand side and an element from the left hand side. So we take that away. We take 51 and 30 away, and we ended up with 37. 37 is going to be our median in this right here. I wrote it to scale here so that you can get an idea where the numbers are. And look, 51 is repeated twice. Okay, so even though it appears twice, but it's another element in the set. Right, this could represent 2 people who have the age of 51 each. Right, that's why you included 2 times. And representation here, I put the 2 times so that when we do the example, we take 51, 51 and 30, and so the only one left is 37. So that's our mean, right? 37. Remember, graphical representations are always useful. Now, let's have an example here. Example 3, page 749. Determine the median of an even number of pieces of data. This is important, even, right? Because when you get the representation of an even set, basically you ended up with, in this case, for example, A is equal to 9, 14, 16, 17, 11, 16, 11, 12. This is not organized in ascending order, so we need to rank it in ascending order. This is crucial. Make sure that you pay attention to do this. So we'll organize it in ascending order. So we have a 9, 11, then we have another 11, then we have 12, 14, 16, we have another 16, and then we have 17, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Make sure that we have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. And now to find the mean again, what we need to do, we take away 1 from each extreme, right? From the left and from the right. So you get 1, 2, 3. So we are left with 12 and 14. So then, in this case, our mean is going to be the division of 12 plus 14 divided by 2. And this is 26 over 2, that's 13. So this is the mean. So the number that we have here is basically these 2. Now, let's look at example B. We have a set that is consisting of 7, 8, 9, and 10. Now, we'll do the approach again. We take one from the left and one from the right, one from the right, one from the left. We ended up with 8, 8. So we need to take the average of these two. It will be 8 plus 8 divided by 2, and this was 16 divided by 2 is equal to 8. So the median for this set is equal to 8. Another term that we need to know is the mode. The mode is the piece of data that occurs most frequently. We have the same example of number 1. We have 30, 31, 51, 37, and 55, right? This is not organized in ascending order, but we're just looking for the mode. So it's the number that repeats most. So it's 51 is the one that repeats. So the mode for this set is 51 years, right? A note, a set can have more than one mode. Like, for example, if there are more numbers here that repeat, like 40, 40, 40, then, that's another mode. So you can have a bimode or many, many other modes. The idea is to collect the data and try to organize it and try to interpret it using statistical definitions. Now let's move to the mid-range. The mid-range is a set of data that can be calculated using the following formula. So mid-range is equal to the lowest values plus the highest value divided by 2. In other words, we're in the middle for this element. So we have, using exercise 1 again, set is already here, 30, 21, 51, 37, and 51. So the lowest value is 21 and the highest value is 51. So we add this number, you get 72 divided by 2, you get 36 years old. That's the mid-range for this given set. The range. By the way, this topic appears in the following section, but I decided to include it here so that they're contained in one set. And the range is defined as the range of a set of data can be calculated by using the following formula. Forget about that. Formula. Range is equal to the highest values minus the lowest value. Okay, that's the range. So if we have an exercise to calculate the range of a given set, we have 29, 12, 26, 18, 19, 8, 9, 8, 9, 16. We arrange it in ascending order. That's a good practice to do that. We get 8, 8, 9, 9, then we have 12, 16, 18, 19, 26, and then we have 29. We organize it in ascending order. So the highest value is 29, the lowest value is 8. We subtract that, we get 21. And if you have a physical representation, that will be the range, right? How wide the data is distributed there. Very important concept. Now we move into an area that requires some careful attention. The measure of position are used to describe the position of a piece of data in relation to the entire set of data. So there are two measures of position, and these are the percentile and quartiles. So percentiles are the one where you have a set of numbers and you divided the whole thing into 100 pieces, right? And then you have your percentiles right here, up to 99 percentiles. So this gives you like a position where a given data is corresponding to. And then when you use this approach of percentile, you can decide on a given point, right, the reference of this point to the one that are before and the one that are after. So it gives you a measure of position, right? Where a number falls, you can then tell the story whether it belongs to the lower part or the higher part, or where it stands in reference to the rest. Another measure is the quartiles. And in this drawing that I have set up for you here, typically we always talk about the first quartile, the second quartile, and the third quartile. But if you look carefully, the whole set of data is divided into 4 chunks. 1, 2, 3, 4, equally distributed. And so we have to pay attention into these calculations. And also, it's important to know that the Q2 is always the median. Now let's have an example here. Example 7, page 751. English achievement test. Cara has a score of 81st percentile. Explain what that means. So here is a pictorial, right? It's 81st percentile. So that means that somehow 81% is represented by 81 percentile, 81st percentile. So graphically, you know that it has 81 below and 19% above. So if you want to give an explanation, you might say that the 81st percentile means that it's about 81% of the score, right? And are below that score. So you have a 81%, and therefore Cara scored better about 81% of the students. So it's right here. So she's above all the other students right here. But on the other hand, when you look to the upper numbers here, you will see that Karen is also 19% below of the higher score. And so other students scored like a 19% above her. Okay, it's a way of comparison of the data. Now, finding quartiles. Example number 8, page 752. It says determine how long in months the sales staff has been in their current position. Determine quartile 1, quartile 2, and quartile 3. And this is what the set that we have. The set is composed of 27 members, right? These are all the numbers that are here. You can read them. The first thing that you need to do is you need to list the data in ascending order. And because there are 27 members, that means that the calculation is going to be easy because the numbers are going to correspond exactly to where they are going to show up in terms of the mean. For example, the median. The median, if we were to calculate this number first, we have to walk again from the right and from the left. We walk one, then we go to the next one, we're next to the next element, and so forth. We continue to move slowly and carefully, making sure that we are covering all the elements. Now we get here, now we continue here, this here, this one here, this one here, and the one that is left is 17, right? So we did that. 17 is the one. So our Q2 is equal to 17 here. That would be the answer. Now we need to either find the Q3 or Q1. If we want to do the Q3 first, then again we have to walk from the rest above the second quartile. We have 1, 2, 3, 4. So we're left with these numbers here. And then finally is 24, the only one that is left here. You can see when we walked, so it's 24th. So our Q3 is equal to 24. Now to calculate the first quarter, we do it this way. We walk from this one, 1, 2, 3, 4, and then we are left with this. We walk 1, and then the one that is left is 9. So 9 is the only one that is left here. So that would be our first quartile. And this is the way you do it. You know, when working with numbers. Now, if you have a large number, sometimes there is another way to do that. But this is just to show you pictorially how you encounter or uncover what the first quartile, second quartile, and third quartile are in terms of the numbers. Now we have another example here where we're using the same set, right? We're going to use the same set, 27 elements, and those are the elements. And so in this case, what we're going to do is that we're going to use some calculations. Okay, this is good when you have a huge amount of numbers, and it's easier, right? If you just know how many elements you have in the set. In this case, we have an odd number of elements, right? So in this case, we do the following. We know the first quartile represents 1/4, right, of the total. So you multiply 1/4 times 27, you get 6.7. And this number does not exist in the set, but is representing the position. So instead of 6.75, basically you say that the number is in the 7th position, right? So this is the next, if you run the number to the highest number would be 7, that would be the 7th position. If you go back to your set of numbers that you have before, you count 1, 2, 3, 4, 5, 6, 7, right? So that's the number right here that we have for the first quartile. Let's do the second one. So the second one will be half, which is 50%. And so multiply half times 27, you get 13.50. And this represents the 14th position. So we go back again to the data that we have. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's Q2, which is right here. So Q2 is equal to 17. Right? It's the number that is in that position. And now for the third quartile, we do 3/4 multiplied times 27. When you do this calculation, you get 20.25. And this is pointing to position 21. So in position 21, we have to count again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there you have 21. So Q3 is 24. Q2 is 24. And so this is what you need to know for this section. In addition, please remember, this is important for quartiles. List the data in ascending order. Right? We're going to rank from the lowest to the highest number. Always do that. Don't just try to calculate what the median or first or second quartile without organizing. It's very crucial that you do this. The next thing that you need to remember is that the Q2 is the same as the median, right? And if you don't remember what that is, I have a reminder for you here. Pages 748 and 749, you will find the definition and how to calculate that. And again, the quartiles divides the set of data into 4 parts. 1, 2, 3, 4. So basically, it's like if you were dividing this into 4 pieces, it will be the 1, this will be 2, this will be 3, and this will be your 4th part of that calculation. And again, when you're looking at this, the first quartile is the first quarter, second quartile is the second quarter, and the third quartile is the third quarter here. Right? We always talk about the third quartile. We don't deal with anything above here. This is really important. Make sure that you pay attention to the homework. Do it step by step. Don't rush. This is the time when you need to relax when you're doing this work. You need to have some interpretation of the data. Don't just jump and try to solve it like plugging numbers into a calculator. That's not the way this is done. It's more like reasoning, or all the steps that you need to do. If you follow these procedures, you will get to the right answer. And please do your homework. Thanks a lot.